All right, so we are going to write bubble sort and merge sort. So let's make a directory. So, bubble sort. How do we start?
We started with a function, of course, called bubble sort, and we have a parameter of unsorted array.
Okay, and what's our general plan? Like if we were to pseudocode this, what's our plan?
Oh, like what? We are comparing the first two items in the array. Come on, guys, help me out, people. It's a team effort. Then, after we compare those two items, we're gonna swap the item that is smallest.
Yeah, so we'll swap if necessary.
Yeah. Okay.
We're going to have some structure though. Remember, I had to go through the array many times before I was done. So how do we know how many times to iterate through the array?
Create a counter.
We can create a counter, or and I'll just do a for loop. So I'm going to iterate over array indexes. And then I'm going to compare pairs of items and swap if necessary. That's basically my algorithm. It's O of n squared because this is O of n. We're doing this n times, where n is the, whenever you say runtime complexity, you should always specify what n is when you say O of n. So this iteration is going to happen n times, where n is what?
The length of the unsorted array.
The length of the array. And then here, I'm going to do this n times for every loop through this. So I'm doing something that's O of n times O of n squared. Okay. Did you guys use a for loop to iterate over indexes?
We did.
Let's start at 0.
No.
No.
Did we not? Oh, go. No, yes, Bonnie. You do it.
You're going to be a great dev advocate. You're so encouraging. Okay. Why did you guys think of starting, I'm guessing you were thinking about starting at the length and counting down. Why did you think about doing that?
To keep track of what was already sorted at the end.
Ah, okay.
Inner loop only has to go up to what the outer loop value is.
Yeah.
All right, yeah. So now, if I'm on my first pass, I'm going to look at everything. But if I'm on my second pass, I'm only going to look at up till the last item. If I'm on my third pass, I'm only going to look up to, whatever. So now for my inner loop, I want to start, I'm going to start at 0, fine. And I'm only going to go up to, and I don't want to keep saying unsorted array dot length. Well, it doesn't really matter that much. Okay. Minus I. I'm only going to go up to where I know it's already sorted. All right, questions on that? Yes.
So when we say unsorted array dot length minus I,
I'm making it items because that was too long.
so in the first loop we're saying item is 0, so item is a 0 its index, right?
Yes.
And J is going to be item minus I, so isn't that
Well, J is going to iterate as well.
uh-huh.
So I'm going to start with 0, although really I probably don't need to start with 0. I can probably start with 1 because I'm going to be comparing I and no, wait, hold on. I'm going to be starting with 0.
So length
Confusing
minus
myself.
I.
Yeah, so this just means on my first pass through,
Mhm.
I go all the way to the end.
Okay.
On my second pass through, I ignore the last item because I know it's already sorted.
But how does minus I tell it to ignore that last item? I guess what I'm missing.
Ah, good. Because my first time through, I is going to be 0.
Uh-huh.
So J, we're just going to be J is less than item's length.
Okay.
My second time through, I is going to be 1. So J is going to be less than item's length minus 1.
Oh, got it. Thank
Cool.
you.
No, thank you for asking.
So we're using I as okay. I totally get it.
So yeah, so
Confusing.
let's actually specify because I got confused myself. What does I represent?
The index of the array dot length.
It does not. What does I represent?
Value.
Not the value.
It's a
And
constant.
it represents iteration.
The sorted We're all just guessing.
Wow, okay, all right, yeah. Okay, I represents what's for lunch today. Okay, so I is, it's not an index here.
It's not.
So I is the pass through count, right? How many times we've passed through the array.
I feel like collectively we said that sort of.
Yeah, I agree. Okay. What does J stand for?
J is the index.
J is the index, and it's actually going to be the lower index of pair we're potentially swapping.
Okay.
We got a question. So in this context, I is the counter.
Yes, but J is kind of a counter too. I mean, you know, they're both counters, but J is representing an index of the array, and so J is counting how many indexes we've looked at, and I is counting how many times we've done our bubble sort process.
No, I guess I'm just saying, like, I guess the way you're using this loop right now is just using it very specifically rather than, like, because the I could represent an index.
Absolutely, yes. And often when we do nested arrays, they both represent an index. But that's not what I'm doing here.
Yeah.
Yeah,
That's
yeah,
what
yeah.
I'm trying to do.
Yeah. No, yes. Yeah, thanks for specifying. I'm not comparing index I to index J. That's not what bubble sort's all about. But it's different. A lot of times when you do nested loops, you are comparing index I to index J.
So what are we doing in this one?
Yeah, so since J, by the way, is the lower index of the pair we're potentially swapping,
Mhm.
we actually want to do items.length minus I minus 1. Did you guys do that?
Items dot.
Because we are going to be comparing
Uh-huh.
right? So if the last thing we want to compare is at the index items.length minus I, then the last pair we want to compare is going to start at that minus 1.
If you just want to like not get confused and just do items length, like how many milliseconds are you gonna save by leaving those things off?
It will scale exactly the same. If I do this, it will scale, it will still be n squared. This is just a better n squared. it's a more optimized n squared, but it doesn't change the
Still
runtime.
do the job.
It'll still do the job,
Okay.
but your computer will hate you for making it do extra work. Okay, so we agreed on the two things we're comparing, and then we're going to swap them. And now here's something I know you can do in Python, but I have to check to see whether you can do in JavaScript. I'm going to say if items j is greater than items j plus 1. I'm doing this because I'm not gonna use that. Then Puneet, maybe you can tell me whether I can do this. Can I
That's clever.
you can do it in Python.
I spliced. I shrunk for just. No, I'm kidding.
Yeah, you couldn't do it though. That would look like
Yes, thank you.
You have to have like one temporary variable.
Whatever.
Explain, so let's continue.
You add, so you assign, like, say, items j plus 1 to items j plus 1 plus items j, and then you assign items j to items j plus 1 minus items j, and then you assign items j plus 1 to items j plus 1 minus. If you really want
Or you use Python. Which do you choose?
Bonnie, can I ask a question though?
Yeah.
Why didn't you, in your for loop, set j to equal items at I plus 1? Or, why didn't you set j to equal the next item in the item collection?
Like here?
Yeah.
Well, because j is an index counter. And for every pass through the array, we need to start at the beginning. Remember, every time I bubbled somebody up to the top, I went all the way back to the beginning of the array.
Isn't that I's job though?
No, I's job is just how many times we've passed through the array. So I is counting how many times I walked from the beginning to the end. That's what I is counting.
Okay.
Yeah.
I see.
Yeah, thanks for clarifying. Okay. All right, so, Celeste had a much cleverer way of doing this that would not take up extra space. So talk to Celeste if you don't like taking up space. Okay, so, okay. Will this work?
I don't think so.
You don't think so? Why not?
Well, we're not returning anything.
Bummer. Okay. We are actually modifying the array in place, however, so we might not have to return anything.
Well, also, okay, so while it goes through the first for loop, the second for loop is just swapping the two. It's saying this is equal to that, that is equal to that. Maybe it'll work. Oh, yeah, we didn't talk about that.
Okay, so let's, looks like it worked to me. Can we make it better? Yes? How can we optimize? Yeah, what if you had an already sorted list?
Then you don't need to sort it.
We absolutely do not need to go through I times. Right? basically, if you go through once without making any swaps, that means that the list is sorted. The array, we're not in Python. The array is sorted.
A swap variable or something that's Boolean. Equals true or false.
Then what do I do?
If you perform a swap, then set it to true.
Okay.
But then if you have and it stays false, and if you get through that if and it's still false, or that loop and it's still false, just return.
Don't you make a variable outside of the inner loop?
Ah, yes, I do. This is where it's really important. Because I don't want to reset the variable for every swap. I want to reset it here for every pass through the array. And then I say if did swap, or I can just say if not did swap. What would I say here?
Return the list to the
I'm not returning anything because I'm sorting in place.
return the,
You could use break too, if you like that syntax instead.
yeah, that's what I did. Break. And then or else return or else.
I don't think you need an else.
Yeah. Else,
Well, else you have to start this sort again. No, you don't.
no, you just continue. And this is a place where it'd be nice just to do this. Okay, optimized, but still n squared. Because runtime is pessimistic, so we want to think about the worst case scenario. And the worst case is that it was, I think the worst case is if it's reverse sorted. Because then everybody has to bubble. Okay, so cool, bubble sort. All right, merge sort. What's our strategy here?
Math floor array dot length divided by 2. That's our strategy.
Okay, this is a very important number. What's our general strategy?
Divide and conquer.
Divide and conquer. And by the way, whenever you have a divide and conquer strategy, that's indicating a log n. That's why this is n log n. Split array in half. And then what?
Do it again.
Yeah, like if either array has a length of bigger than 1, split it again. But like keep splitting until the array has a length of 1.
Run merge sort on each half.
So we're going to do a recursive.
It merge sorts recursive.
The half is, if you're doing the splitting in halves, you have to do something.
Not really. You still run merge sort on each half.
How do you have to choose like which way to,
Yeah, and Stephanie chose for us.
oh, I see.
We're going to split the array in half. We're going to run merge sort on each half. Because merging two sorted arrays is not hard. You do that picking whichever the minimum of the first, the minimum of the first item of either array. If you know they're both sorted, merging two sorted arrays is not hard. Getting two sorted arrays, we've got a function that sorts arrays. It's called merge sort. So that's how we're going to get two sorted arrays. And this is how we're going to determine how to sort them. Now we've got to be careful because what does recursion need? A base case. So what is our base case? How do we know when an array is sorted and we don't need to run more merge sort on it?
And the new array has the length of the old array.
Just because the array has the length of the old array doesn't mean it's sorted. So I am breaking an array in half, and then I'm feeding each half to merge sort to sort it.
But isn't it going to be sorted into a new array? And that new array, once it hits the length of the array we started with, then it's done. Right?
No, because it is going to be sorted into a new array, but then I'm going to merge these back. And when I merge them back, it just means that I popped off the recursion stack. It doesn't mean that I knew that these two were sorted. It's sort of like I merge these back when I know they're sorted. It's not I know they're sorted when I merge them back. When the length is 0 or 1, you're right both times. That is an automatically sorted array. So, base case. And here you can do merge sort in place, but merge sort is actually more difficult to do in place. So we're going to do it assuming that we have infinite amount of space to work with. Okay, so we're going to return items. Fair? So the recursive case, split, sort, merge. So actually this is the recursive case here. Okay. So Stephanie helped us with splitting. So I'm going to say const middle index is this. Okay, so what's my first array?
Items not sliced from 0 to middle.
Okay, and then array 2 is going to be items dot slice what?
Start at the middle index.
Start at the middle index,
And then go to the array dot line.
which I don't need to do. I think that's just by default, it goes to the end. We can check that.
You're right. I'm doing a new Google experiment where Google's now right here.
Google's in your head? God damn. All right.
Get anything.
Okay. Okay, so this is the split the array in half. Then run merge sort on each half. This is faith-based programming, right? This is like, okay, I'm assuming merge sort's going to do the right thing and actually sort these things. Mm-hmm. And then we're going to merge the sorted arrays. This is the most complicated part of the algorithm, merging the sorted arrays. It's going to be a while loop. Oh, 1142. This is like, okay.
We did the most complicated part of the array. So we started from the bottom.
Ah, you did the merging the sorted
Yeah.
arrays. Okay, okay, cool. I mean, this other stuff, it's complicated conceptually to like think about how you're doing it, but the code itself is relatively simple. All right, so what's our strategy? What's our strategy for merging the sorted arrays? We talked about looking at first item in each array and put lower one in, or add lower one to new array. Right? So let's do a const results equals an empty array. How do I know when I'm done? When at least one of the arrays is empty. So while sort1.length is greater than 0, or sort2.length is greater than 0. What? And? No,
it'd be
one of them could be empty.
But if one of them is empty, then I can count that as a kind of our result.
Yeah, but I don't want to do a bunch of logic outside my while loop for how to do that. All right. So while either array still has items, we're going to look at the first item. Well, so now I'm going to do this logic that Celeste thinks is fun. I'm going to do it inside here. So I'm going to say if one array is empty, just glom the other array onto the end of result. Do you understand why? That was like when I was just like taking people, I'm like, okay, you're done. So if sort.1.length is 0, how do I add an array to the end of the other array?
Result data.
I think we need to use
Oh,
concat.
concat.
Push
Yeah.
is what you use if no, push is what you use if you're putting a single item. If I did push here, then I would end up with just one more item in my array, and that one item would be an array. I know it's really hard to pay attention when food arrives in the back of the room.
Just this.
Yeah. Okay, so can I do that?
So you're saying if sort1.length is, oh, yeah.
And then I need to empty out sort2 so that, or I can even just break here, right? Like, screw you, I'm done.
That makes sense.
Oh, I don't even need an else because I broke. Okay, so now we've done the easy stuff. Now we need to actually do the merge. How does this work? How does the merge work?
Yeah, you the first item in each array, and whichever one is smaller, you push it to the new array.
So first I need to remove it from the array. How do I remove the first item?
Shift. We learned about shift and unshift.
Do not pop.
Yes.
Pop is the end of the array.
Pop 0.
Oh, yeah, that's in Python. I don't know whether you can do that in
Shift is going to add like time complexity to our algorithm. Though.
Yes, good. I'm glad that makes you really uncomfortable. Yes, Shift is going to add. Actually, I don't need to do an item there. What is the runtime of Shift?
O of n,
Why is it O of n, Patrick?
because you have to like after you remove the first index, you have to like go and reassign the index of every single item to be one less.
Yes, very good. So, and what's the runtime of Pop?
O of 1.
Why is runtime of Pop so much better?
Because you don't have to like reassign the index of every single item.
So
You
if
don't
start
have to
with one,
reassign the index of every single item. So this is not an optimized merge sort. As a matter of fact, it might not even be n log n, but you can figure out how to do it with Pop. Oh, we've got time. Let's just do it with Pop
let's do
instead.
it. So pop means that we're gonna start from the back, correct?
Means that we're going to start from the back.
Yeah. And then we know we don't have to ever look at it again
Then we don't have to ever look at it again.
or reassign its index.
So if I do, no, wait, that's not where I want to. So now what I can do is instead of sort 1, I can do -1. That works in JavaScript, right?
I don't think so.
You're
That,
trying to
like,
get to
works
the
when
end
you're
of the
trying to do
length?
like slice and stuff like that. I don't think when you're looking up, you can look up like a -1 index.
I'd say I'm 95% sure it would work because it would be ridiculous if it didn't, but I don't know, node is ridiculous. So,
Yeah, look, you can do it when you're
You
doing
can do
stuff
it
like-
dot length.
like-
Can't you do it dot
Node,
length?
are you serious?
Patrick, can't you do dot length -1?
Yeah, that's how you have to listen to n. You have to do like a at a dot length -1.
Oh, Bonnie, come on. Maybe you could get the guild to give us more time to learn Python.
Like it should.
I think JavaScript is weird because I think it's like when you're slicing or when you're splicing, you can pass -1 and then it will go to the end.
Yeah.
So you can do it with like some functions, but you can't do it when you're just looking up.
Thanks for the hint.
If you're working on like some huge app, you should just like write a prototype for grabbing the end of something, so you don't have to do like array dot length -1 every time you want to grab the last item.
Or use Python. Okay. So now we're going to do result.push pop. But now we have another problem. Why do we have a problem? We've got a bunch of problems actually.
Because we're concatenating.
It's going to be reverse sorted. And because it's reverse sorted, we actually would have to reverse these.
So
And
if
we can just return array dot sorted.
Isn't like reverse just adding the runtime complexity back though that Shift was doing?
Yeah, that's what
So we're not really saving runtime complexity by doing this.
Well, no, because we're going to do reverse once at the end, as opposed to doing reverse, as opposed to having an O of n. So we're going to add an O of n thing at the end, as opposed to adding an O of n thing every time through this loop.
But it's still like O of n and on, so like runtime complexity.
Well, if it's n log n and we're adding an n log n plus n is still n log n.
I just have to think about it, I guess.
I get you. I am not an expert in optimizing merge sort, so there probably are better ways to do it. Actually, yeah, I mean, a lot of the better ways also, in order not to build all these new arrays, is you use pointers in the arrays, you know, and keep track of stuff rather than actually popping everything off and, you know. All right, so now we have to reverse. What did I call it? Results. Reverse. What do we think? Why are you unhappy? What?
What is it saying?
Cannot redeclare block scoped variable. Nums doesn't exist anywhere else in here. All right, whatever.
Call it something else.
And now I am not doing it in place. So I'm going to console log the result. Perfect.
That's what we got. That's where, yeah.
That's what you guys got too?
Yeah, that's where we got. That's what we got stuck, yeah. The same thing happened. So at least you know where we are.
Okay. So let's figure out what we did wrong. Clearly, I have not done merge sort in long enough, but that's good because I have 6 minutes to fill anyway. So, okay. So let's just console log. I'm a big fan of console logging. Okay, so let's just see what it's returning here. And then up here, I want to see just see what happens. Let's okay, so it did take like the first 3 items, and then I have a feeling concat doesn't work the way you think it does. So let me just say I have a feeling that's our problem. Better.
But it's not sorted.
Oh, okay. Well, that's a problem too.
It's sorted in the way where I looked at the first number in the array. Like 5 is before 6. But -3 should be before 5. Oh yeah, it's not sorted at all.
How did it start? So it's just in wacky order. Okay.
So I think there's something in our reverses that we're reversing.
Yeah. Can we do it without the reverse? Let's do it without the reverse. All right. So although this console log stuff is interesting, so I'm going to leave it. And look, it's just so much more beautiful this way.
Yeah, we'll help you debug it.
Okay, sounds great. Thank you. All right, let's try again. Just because. So now what do we have? Okay, so I did not do the unshift and the reverse properly because that's not generally how I think of merge sort. I think of merge sort like in terms of the logic and not in terms of optimization. So you notice that it broke down the first half into its base cases, and then it this one, it was this array, and then it merged those two. Then it broke the second half into its base cases. Then it was this array, and it merged those two. And then it merged everything. Actually, let's put some more debugging in here just for fun. Let's say, now we'll say, okay, so it returns this, it returns this, it returns this. That is merging these two things. That's too bad that it doesn't give me,
Yeah, why didn't it keep the brackets?
I don't know, but I can take care of that.
Uh-huh.
Python would.
But I mean, like, if you console log an array, it keeps the brackets.
It
So,
does.
Like when you're console logging the string interpolation of the array, it doesn't.
Yeah.
Not yet, Patrick. That's a bug. Fix it.
It's a feature.
Okay, so first we merge 3 and 6, and we get this. Then we're merging 1 and 3 and 6, and da 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 da. So this is interesting if you want to see sort of like the order of everything that happens. Not a bad idea as you are going out into your interviewing lives to be able to code merge sort from scratch. It's not unheard of for somebody to be like, choose your favorite n log n array, n log n sort, and code it for me on the whiteboard. Yeah, well, so maybe you like quicksort better than merge sort.
Is quicksort and login?
Yes. So let's go to. Yeah, well, the Rome was not the fastest coded project. Okay. Okay, so bubble sort, merge sort, quick sort. So here's a comparing sorts. Does this one tell you? Like you can like it has the algorithm for all of them. It has so you can look. This one, I'm sure you can, there are a bunch of pages that will tell you what the actual runtime is, but insertion, selection, and bubble are n squared. Shell, I can't remember if it's n squared or n log n. Merge, heap, quick, and quick 3 are n log n. It has been proven that n log n is the best you can do for sort. You're never going to do better than n log n, but you can do worse. So if I play all, you can see like how all of the sorts work. You could also just play any of them individually, but you can see like quick sort in general is great unless you have like few unique. And look, selection was the total loser there, right? So, so this is just fun. Like you're like, but like, look, you can also see bubble is like, like bubble is pretty slow, but not as slow as its brother selection.
Do you know why it's called quick 3, not quick 2?
Yeah, I don't know. Quick 2 must be something else. Alex. Okay.
Try to sneak in. No, that don't work.
Okay.
We got free earlier.
Okay, so let's stop the share and
Let's eat and talk.
let's eat and talk.